In this tutorial, I want to go over pointer declaration and pointer initialization. In the C language, understanding pointers is fundamental to being a good programmer and maximizing data structures. In short, data structure is a description of how data is organized in memory, and many data structures are built from objects pointing to or referring to one another. Pointers provide an alternative way to pass data between functions. To this point, if you haven't used pointers, you've been utilizing pass by value. With pass by value, we can only pass a copy of that data. Let me use this book as an analogy. So with pass by value, I'm basically making copies of the pages from this chapter book. And when I give that copy to someone else and they make changes to it, for example, highlight it, make notes on the side and modify it, the actual book is not changed. The only change being made is to the copy of the Xerox pages. And this is where pointers come in. Pointers allow us to make changes to the original book. So whatever change we make changes the original book, because we can directly go to the book or to the address of that memory. And in this case, we can directly go to the book, make changes, and when the user gives this book back to the original owner, the changes are permanent. It's still on the pages. As mentioned in the introduction, every file with data lives on either a disk drive, a hard disk drive, or a solid state drive. These drives are used for storing. We can't directly go there and do work. Manipulation and the use of data can only take place in the RAM, and so we have to move or transfer data from those storage area to the RAM. And the RAM is much smaller and it's also volatile, and that means all of the data in the RAM is destroyed once we turn the computer off. When we move things to the RAM memory, it takes up a certain amount of space. Think of memory as a big area, this white area. And imagine in this white area are a whole bunch of bite-sized cells. With the size of operator, we can determine the amount of space that a variable takes up. So for example, an integer takes up 4. Here I've drawn a memory cell for int. And obviously each cell will have its own unique memory address. So let's take a look at the size of a char. A char takes up 1 byte. What about a float? Floats take up 4. Let's take a look at a double. Doubles take up 8. And finally a long. And longs take up 8. Now these sizes may vary depending on your system. Now the main purpose of a pointer is to allow us to modify or inspect the location to which it points. So any of these data types. And that's done by dereferencing the pointer, but we'll get to that later. And so whenever we declare the pointer, or whenever we want to point to a particular memory location, the pointer's data type must match the variable data type. So for example, let me declare an integer and let me initialize that integer to the value of 10. When we declare a pointer, we have to use a unary operator called an asterisk, and I'm just going to call it PTR. The asterisk can either go next to the variable, it can go in the middle, or it can go next to the data type. It's all a matter of preference. I like mine next to the variable. So in short, this is how you declare a pointer. So you have your data type and your pointer name. And in memory, this is what it looks like. So if this is main's stack frame, we have our number, integer with an address of 0x100, and we have our pointer with an address of 0x200. Now to initialize a pointer, I have to use an address operator, and that address operator is the ampersand. Because pointers hold addresses, I have to store an address to it. So for example, if I assign number to it, number is not an address, it's the integer 10. And so if I print out our pointer, it gives me a funky value. It doesn't return 0. So that means that there is an error in our execution. And so in order to store an address to a pointer, I have to use the ampersand, and this is what the ampersand looks like. And what that does is it stores the address of number into the pointer. So if I print pointer, it gives you a 10. So if you look at this right-hand side, this pointer, when we assign ampersand number to it, this will now hold the address of 0x100. So the way I think about it is I think of this pointer as like a remote control that allows me to point to a television, or in this case, a memory location. And with this remote control, the dereference operator, it allows me to make changes to our number variable. So now when I go back to my code and I remove this dereference operator or the asterisk and I print this, it should give me an address, 6487836, and that is the address in integer value of PTR. Now back to the logic of the remote control. If I assign a different number, 23, to star PTR, I'm modifying the actual address, or the data that this address is holding, to our number variable. If I print it, it should change to 23. And let me also print number to show you that number has changed. So here on line 14, if you notice, I'm printing out the number, the value of number. And notice I have a 23 for PTR and a 23 for number. So I was able to change the value that number was holding by using a pointer. So if I comment out line 11 and not change the value, when I compile this, I actually get 10 for both star PTR and number. There it is. And this is how you declare and initialize a pointer. So in short, if I were to print PTR, this would give me the address of the variable that it is holding. And if I print star PTR, this will give me the value of the variable that it's holding. So think of PTR as basically a alias for number. So this is number, star PTR is its alias. Thank you for watching.